have the most sago plantation in Malaysia, sago bark waste is abundantly available as agricultural waste from sago processing plant in Sarawak. Today, I'm going to present to you Sago Bark-derived magnetic sorbent, a way to utilize and convert the sago bark waste into a value-added product and at the same time decontaminate polluted water sources. My name is Fong from University Malaysia, Sarawak. Sago bark is one of the main byproducts produced by the sago mill industry during the sago starch extraction process. The sago processing industry in Malaysia disposes of exceeding 20,000 tons per year of sago bark waste. It is estimated that 1 ton of the sago starch produced generates 0.5 tons of sago bark waste. Sago bark is applied as a small add-on for the fuel in the sago mill and also as animal feed. However, the majority of the sago bark is usually burned to counterbalance its build-up. The sago bark poses growing concerns for the environment if it is not properly disposed of, as the sago bark can have a distinctive impact on the environment, mainly in the ecological sustainability system. Most of the conventional adsorbents were hard to be separated from water and tended to agglomerate. Under these circumstances, the sago bark waste are utilized to produce the sago bark-derived magnetic sorbent. The magnetic sorbent has gained significant interest as the material can overcome the aforementioned shortcoming of the conventional sorbent and exhibit enhanced separation efficiency via magnetic sorption technology along with the utilization of the sago bark waste. The magnetic sorbent is developed via the impregnation and carbonization methods. The sorbent responds towards a permanent magnet. The sorbent samples are attracted to the barrier of the glass vial in dry without aqueous solution, and that with aqueous solution conditions when the permanent magnet is positioned at the external barrier of the glass vial. The ferromagnetic property of the sorbent assists in separating the sorbent from the aqueous solution after its application in contaminants removal. The Fourier transform infrared FTIR spectral analysis shows us that the surface functional group of the magnetic sorbent are C single bond C, C single bond OH, C single bond H, COO, and FeO, OH, as well as CO. The scanning electron microscopy analysis discloses the surface of the sorbent is porous with embedded of iron oxide particles on the pore surface. This result is supported by the outcome obtained from energy dispersive X-ray analysis, EDX. It is proven that the data obtained from the EDX as the high iron percentage is found on the magnetic sorbent compared to the raw sago bark. The carbon element on the surface of the magnetic sorbent is lower compared to the sago bark, which is due to the iron deposition on the surface of the magnetic sorbent. The removal of lead and copper ion are attainable within 3 hours, with the maximum monolayer adsorption capacity of 172 mg per gram for lead and 12,500 mg per gram for copper ions. So the removal is at least 98%. The application of the sago bark-derived magnetic sorbent on the removal of magnetic blue dye from aqueous solution has shown significant effect. 99% of removal is achievable within 15 minutes. This invention highlights low material cost of producing magnetic sorbent by reusing the sago bark waste. The magnetic sorbent has excellent ferromagnetic property which can easily recover after decontamination process. This supports the circular economy system The magnetic sorbent has the ability to absorb organic, the dyes, and inorganic, the heavy metal ions, contaminants. Thus, it has great commercial potentiality for water and wastewater treatment. Will this Sago Bark-derived magnetic sorbent give us a sustainable future? This magnetic sorbent is good for a sustainable environment in ensuring sustainable consumption of the sago bark waste and its production patterns. It will increase the profit for the farmers as well as the agricultural industry. Thus, this magnetic sorbent is highly potential alternative in replacing more high-priced adsorbent for contaminants removal. Thank you very much.